identifying and graphing polar equations. All right, so when we were talking about this, this is still polar, right? The thing that we changed yesterday was rectangular. So we're just going to identify this. So now this would be my R. So if I were to look at this in my coordinate, this would be 3, 0, right? Yes? Okay, so 3, 0 would be my function. So if I were to try and graph that, so it would go over 3. And it goes up 0. Yeah? Okay. All right, so let's look at the other one. So the other one would be this. What is the radius of this one?
0.
So it'd be 0, comma, pi over 4. So my radius is going to be 0, comma, pi over 4. So the radius, that means the length of it is going to go 0, right?
Yeah.
But it's going 0 in what direction? So in the pi over 4 direction. So pi over 4 should be right here. So it would be in this direction right here along this. This is technically a polar coordinate graph. So it would be there, but it's going 0. So it'd be right there. So it'd be just that dot. Okay.
You don't have to show the dotted line.
No, you don't need. I did the dotted line so you guys could see where pi over 4 is, because this is actually all my things. We have pi over 4, and then what does this one go to? Let's see, hold on. 1, 2, 3, 4. So that means that this one's going to be. Trying to figure out the increments on this one. I can't remember this one. I know this is supposed to be like pi over 3 here, and this one's supposed to be pi over 6, and that makes this one pi over 12, and that this one's going to be 5 pi over 12. There we go. And that's all I was trying to do. There's dotted lines already there for those, so. Yeah. All right, so on that one, that's all we're going to get for those. Now, if I were to change these to a rectangular, so this is not one that we already have. This is one that's just going to be this is only asking for polar, but if I want to change this to rectangular, how would I change that to rectangular? This goes by what we did yesterday. R. Okay, so it would be, it's going to be R cosine of theta, right? Comma R sine of theta. And that's how I'd actually turn it into my rectangular. So R, and so let's take a look. So R is going to be 3, but then the cosine at 0 for this one right here is going to be 0. So no, cosine is 1. So it's going to be 3, right, parentheses, and this one is going to be 3, right, times sine of theta. So sine is 0, so it's going to be 0 right here. And this is rectangular form. And so that means that in my x and y coordinate, so it's going to just look like this. So it's going to go right 3, up 0. So just going to be a dot right there. That's rectangular. Is this super easy?
Yeah.
Okay. All right. So I guess that's it for this. No, there it is. Okay. Identify and graph the equation. So we have r sine theta equals 2. Okay. r sine theta equals 2. So that means that is my y value, right? So I'm going to get that my value, so it's going to be 2, so that's going to give me my direction. So it's going to be up 2. It's going to be up 2, and then what's it going to be for my x value? Is there an x value there? No, there's no x value, right? So since there's no x value, that's going to be 0. So that my graph for this one right here would just be straight up 2, right? Okay, what about this one right here? Let's go back to A. Let's look at A a little bit more. What's the radius on A? Yeah, radius is going to be 2, right? So what's the theta going to be on A? Which direction does it go? Straight up, right? So what's my angle going to be there? Pi over 2, right? So it would be my r is 2 and my theta is pi over 2. What's next? Okay, we got all that. So let's try B. All right, think about B. What are we going to do with that?
R by sine theta.
Okay. So don't I know that basically I have sine squared theta plus cosine squared theta is equal to r squared, right? Yeah. We did this a while ago, right? I think it was at the beginning of 9 somewhere. Okay, so could I use this to try to get it a little bit better? Could I try to use this to isolate this a little bit better? Because if I divide by sign, that's not really going to help me out, right? No, because I'll have both variables over there. I really don't want that. So using this, what could I try to do for this?
Square
Square it?
it. R squared equals 16 sine theta squared.
Okay. So could I multiply both sides by r? Would that get me my r squared? Okay, I could do that, right? So I could say that r squared is equal to 4r sine theta okay, so what could I do with that? Okay. And see what you can do with it. A lot of these types of problems are stuff that you're just gonna have, it's not gonna be like a straight answer every time. You're gonna have to manipulate it. You're gonna have to play with it. It's not always gonna look like, oh, this is like so obvious, this is where I need to go with this. So I just know that, you know, I started with an identity. Okay, so, because it wasn't in the format that I need, right? Did you plug it in? You see what we get? Is it gonna look like this, where it's sine squared? Equals what can I do to manipulate this? I don't like the sines and cosine.
Or not 0, 1.
Yes, not one, but
Negative.
so I could do this. What is r sine theta? What is r sine theta? Give me a variable that I use for r sine theta. That's y. So I'm going to say this is equal to 4y. And these turn into, what is it?
X and y squared.
Yeah. So y squared plus x squared. Okay.
Is it 4y or 4ry?
4y.
Okay.
Because
Oh, yeah,
r sine is the y.
Yeah, sorry.
Can I move it over? Set it equals 0, then start some f in that. So if we have x squared plus y squared minus 4y equals 0. What's that look like there? Okay. So what would you do? What would you do with that? What shape is that supposed to be?
It's a circle.
Yeah, okay, could be a circle. Circle or ellipse. Okay, either way. Depends on what I get. If it's gonna be like an x squared over 2 or a y squared over 2, something like that, over some value, that'd be an ellipse. But this one could be a circle, right? Okay. So what could I do to actually make that work out?
Add 4 to both sides.
Add 4 to both sides? Why add 4 to both sides?
Because then you can write this x squared plus y minus 2 squared equals 1.
Yes, that's exactly right. I'm just looking for the word for that. What's that called?
The square.
Yeah, completing the square.
Okay.
Yeah, it's completing the square, so it's making a perfect square. So you're gonna have x squared plus y squared minus 4y plus 4, because I'm adding this to this side, equals 4. So I add 4 here and I add 4 here. I add 4 to both sides, and this right here is going to be a perfect square. So it's going to give me x squared plus, now when it factors out, it's going to be y minus 2 squared equals 4. And what does that give me? What does that information give me there now? Go ahead, say it.
Shouldn't it give us the radius?
Yes, it does. What's my radius?
Or is what,
Square root.
-2?
2.
I
So
can't
it's gonna be
remember
2.
which part it was, sorry.
Yeah, so it's right here. So it's always going to be, it's my x squared, y squared, r squared. This is always accounting for my r out here. Okay, so when I actually did it earlier, when I had the x squared plus y, or sine squared plus cosine squared is equal to r squared. So the r is my radius, which is always going to be on the outside over there. Okay, so it tells me that my r, so radius is going to be 2, right?
Yeah.
So I'm going to have a circle. The radius is 2, but where's the center of the circle?
0, 2.
And 0 and positive 2, right?
Yeah.
So I have a circle, equation of a circle. It's going to be 0, positive 2, and my radius is 2. It's always going to be the square root of this number out here. Yeah, this one was a little bit more complicated because it didn't fit directly into one of the things I have.
Oh, centered.
Yeah, circle centered, sorry.
I read cultured.
Yeah, it is
like
cultured.
Custard.
Yeah, it's custard, circle custard.
Circle cut.
Yeah, circle custard. Okay, right here, important things. Line passing through the pole, making an angle alpha with the polar axes. Say a rectangular equation, something like this, inverse tan of A, or just tan of A, sorry. So tan of A of x, and so if it's a vertical line, x is equal to A, whatever that value is. Horizontal line, y is equal to b, whatever that line is. In polar, it's going to be theta is my angle, alpha there, and my vertical line would be r cosine, whatever my a is. My horizontal is going to be r sine, whatever that number is. And typical graph, so here's my different graphs for each one. This is supposed to be just helpful stuff for this. Okay. And here's some more. My circles. And I think that's it, yeah. All right. Okay. Like, share, and subscribe.